Good morning, all of you all.
Good morning.
Good morning. So, are you there? Modak, sir? Good morning, sir.
Hello, good morning. Yes.
Let us start, sir.
Yes, sure.
Okay. Good morning, everyone. On behalf of AGTI's Dr. Daulatrao Ahir College of Engineering, Karad, it gives me immense pleasure to welcome you all to the Day 5, Session 9 of the AICTE ATAL Faculty Development Program on Industry Academia Synergy in Disaster Management and Resilient Infrastructure for Advancing Sustainable Development. It is my pleasure to introduce today's distinguished resource person, the engineer Deepak Modak sir, a highly respected civil engineer and an eminent authority in dam safety, hydropower projects, and resilient infrastructure. Engineer Modak holds a BSc in physics and a BE in civil engineering and brings with him over 3 decades of rich professional experience in planning, execution, and governance of large scale water resource and hydropower projects. He has served as a chief engineer and a joint secretary, Water Resources, Government of Maharashtra, and later as a chief engineer civil hydro project Pune with additional charge as a chief engineer electrical hydro projects Mumbai until his retirement 2014. He has played a pivotal role in critical infrastructure projects such as Koyna hydroelectric project, Varasgaon powerhouse, construction of dam foot powerhouses, second lake tap operations, and underwater repair works, many of which are benchmarks in engineering excellence and disaster resilience. Engineer Modak has been closely associated with national and international dam safety frameworks, serving as chairman of Dam Safety Review panels under the World Bank, MKVDC, and as an expert member of State Dam Safety Committee. Notably, he also chaired the committee that investigated the unprecedented Chiplun floods of 2021, contributing significantly in disaster risk assessment and mitigation strategies. A fellow of Institution of Engineers India and life member of INCOLD and ISRMTT, his contributions have been recognized through several prestigious awards, including the Excellence Award by the Governor of Maharashtra, Vishwesharaya Award, DSK Energy Award, and the Pride of India Bhaskar Award. With his rare blend of industry expertise, policy experience, and disaster management insight, today's lecture will greatly enrich our understanding of industry academia collaboration in building resilient infrastructure and achieving sustainable development goals. We are honored to have you with us today, sir. So, thank you, sir. Let us start the session.
Yes, thank you very much. And a very good morning to you. Just okay. Okay. Don't go screen share. It will become okay. So, good morning, everybody. Um, Before I start my uh, presentation, I would like to pay my homage to Dr. Madhav Kumthekar, who is my childhood friend. Let me tell you one thing that Madhav's mother was serving in Koyna project when I was a high school student in Koyna. And Madhav was also a high school student in Karad at the same time. And during holidays, he used to come to Koyna colony and we used to play together. So he is my friend from childhood. So I would like to pay homage to him. And for that, I would like to just observe half minutes silence in his memory. Om Shanti Shanti Shanti. So let me begin with my presentation. Except so as you all know, dams are indispensable structures for survival of mankind, particularly in major part of southern India. Maharashtra gets rains only in 4 months. Afterwards, the rivers become dry. Water supply for drinking, farming, industry, fishery becomes scarce. But large dams can become a threat and develop hazardous potential if not built scientifically, not built with proper workmanship. So repairs and maintenance to dams is imperative to maintain general safety of the structure and thereby safety of the population downstream. So far as Maharashtra is concerned, the Dam Safety Organization, DSO, situated at Nashik, headed by a chief engineer, is a crucial part of Maharashtra's Water Resources Department, operating under the Chief Engineer, Hydrology and Dam Safety and Jalavidnyan Bhavan, the Indori Road, focusing on inspecting large dams, analyzing safety measures, safety measuring instrument, and developing emergency plans to ensure water security and public safety. The key functions of the inspections are: inspections conduct regular pre-post monsoon and detailed inspections of large dam and associated works. Then instrument monitoring, that is manage and scrutinize data from instruments installed in dams for health diagnosis, analysis, perform dam break analysis and floodline studies, emergency planning, scrutinize and develop emergency action plans. So dam break analysis predicts the devastating flood wave from a failed dam, involving simulating the dam's breach, size, shape, timing, etc., and routing the resulting outflow hydrograph downstream using softwares like HECRAS to create inundation maps, assess risks, and develop emergency plans. Key tasks include predicting breach characteristics of reservoir outflow and flood wave movement through the river valley, requiring detailed topographical and hydrological data for accurate measure of the hazard. The Dam Safety Act, now particularly we would discuss about this. The Dam Safety Act 2021 is an Indian law established to ensure the safe functioning of dams by providing for their surveillance, inspection, operation, and maintenance, preventing dam failure disasters, and creating strong central and state level institutional framework, including the National Dam Safety Authority, NDSA, and state dam safety organizations, SDSO, to enforce standards and policies. The act was Dam Safety Regulations enacted in December 21. It mandates owners to have operation manuals, emergency action plans, and outlines roles for national bodies like the National Committee on Dam Safety, NCDS, and State Committee. State level committees on dam safety, CSDS, oversees state dam safety. State Dam Safety Organization, that SCDSO, conducts surveillance, inspection, and monitoring. And instead, there can be many river basins for each greater river basin. A comprehensive dam safety review panel is formed, that is CDSRP. So river basin corporations, so there are 6 river basins in Maharashtra, namely Krishna, Godavari 1 and Godavari 2, since Godavari basin is very large, starting from Nashik and downwards, then Tapi, Konkan, and Vidarbha. For each corporation, a separate comprehensive dam safety review panel, that is CDSRP, is formulated. particularly for Maharashtra Krishna Valley Development Corporation. Let us see that for Maharashtra Krishna Valley Development Corporation, the CDSRP, chaired by Shri D.N. Modak, that's me. The chairman is D.N. Modak. I.S. Chaudhary, retired chief engineer, is a member. Sharad Govinda Joshi, Dr. Sharad Govinda Joshi is is a former principal of Bhumireddy College, Hubli, and he was also associated with Koyna project when we did the strengthening of the overflow section. He was working as executive then there. Dr. Sri Krishnaya, geotechnical and geology. Dr. Nina Isaac is hydrology and hydraulics. Shri Satyanarayana is member mechanical. Shri Shivaji Bolbhat, again retired chief engineer of our state, construction supervision activity. Superintending engineer SDSO ex officio and concerned superintending engineer of the dam for which we are going for inspections will be the member secretary. So what are the dam safety regulations? Safety is a concern of large and specified dams. Now, what are specified dams? It is clearly mentioned in the Act. So as per Dam Safety Act 2021, key characteristics of a specified dam in India: height shall be greater than 15 meters. Any dam over 15 meters high is termed as specified dam. And crest length, if it is greater than 500 meters. Again, reservoir capacity, if it is more than 1 million cubic meters. And maximum flood discharge is greater than or equal to 2000 cubic meters per second, and has a difficult foundation problems and is of unusual design. Now I have added one more category, that is, it has a high hazardous potential. I will just quote example of this Thosegar MI tank, which is not a measure in all the criteria mentioned above, but there is a Thosegar waterfall, you must be knowing, near Satara, and in monsoon many people come there to visit this waterfall, not the Thosegar MI tank, but they just, sorry to say, but drink and do just funny things, and they encroach into the Thosegar spillway. And the Thosegar spillway is wrongly situated on soft strata. So actually the Thosegar dam has a layout that it has very hard strata on the right hand side, from where they have deep cut of nearly 8 meters, and they have taken out the outlet for the canal. And unfortunately on the soft strata they have situated this spillway. So every year they maintain it by putting gabions or doing concreting, doing this and doing that. And the hard strata below is nearly at 8 meters. So if unfortunately this spillway or the tail channel fails, definitely many people are going to be inundated or blown out by the flood and making high disasters. So there are such 2 to 3 dams which don't fall into the category of this specified dams. They must be taken care of. So such dams are also a responsibility of the dam safety review panels employed by the state government and central act. As per different categories of dams like major, medium, minor, or a small dam, Central Water Commission has specified at least 2 inspections of each dam annually. That is pre-monsoon inspection and post-monsoon inspection. So the inspecting officer is specified as per the category of the dam. The dam can be either an earthen dam with central spillway, earthen dam with side spillway, earthen dam with separate saddle spillway. It can be a concrete dam, a masonry dam, or a composite dam. So as per its type, following components are necessarily inspected. Downstream drainage. Now downstream drainage means it's surface drainage, cross drainage, and toe drainage. The surface drainage here, I mean, is the rainfall drainage. That is, in the rainy season, the rainwater should safely be drained from the downstream drainage. For that, longitudinal and cross sloping drains are constructed. There should not be any vegetative growth. There should not be any obstruction like fallen rocks or other debris. They should be flowing freely and draining the surface water in rainy season or during the heavy storms, heavy floods. Then surface drainage on downstream slope. This is specific. Though even in rainy season or even after rainy season, you should not see any wet patch or any water flowing out of this downstream slope from any jet or any stream. If you see it, you know that you mean there is a piping phenomenon taking place in the embankment. So you should take care of that. So this downstream slope drainage is different than the downstream surface during the monsoon. Then seepage measurement. Seepage measurement means and there are cross drains draining from the water filter built inside. Then rock toe, and beyond that there are the cross drains coming out from the dam through which the water is drained out, and V notches are fixed on those cross drains. So you should keep a keen watch on these V notches or any measuring device put in the cross drains. Then the cross drains meet the toe drain. Toe drain again collects all this drainage and is released into the river. But you should keep a watch on this drainage also, because not necessarily that every drainage comes from the cross drain and the V notches. Even intermittent drainages from the dam meet the toe drain, and you should take care of all these drains and measure them and see that there is no abnormal increase or decrease in the measurement. So if see any abnormal increase, so we have a record of many years of these CPGs. Then season-wise they vary, and that they are as per the water level and the season as well. So if there is any sudden increase in such seepage, you should be alarmed. You should see what is the exact reason of this seepage coming into the toe drain or the cross drain, or what remedial measures should be taken immediately. Then the relief wells. You know that the uplift pressure is many times released through these relief wells, and a sudden increase on these relief wells is also a matter of concern. And I think I forgot to mention the piezometers. We should take measurements of the piezometers again, because the piezometers also tell us the state of pore pressure, if it relates to the phreatic line or otherwise. So we can keep a watch on these piezometers. And a breaching section. You everybody being from engineering faculty, you know that what a breaching section is. You must inspect it every time you go, that it is intact and its level is properly maintained. Then for gravity dams, keep a watch on foundations from foundation gallery or exposed rocks downstream. And there should not be any cracks or oozing or such, deformations seen in the foundation. Then body of the wall of NOF, non-overflow dam, and spillway. NOF of spillway. This spillway has got non-overflow sections on both the sides. So we must see them, that there is no water jetting out, or there is no bulging or anything like that, no cracks are seen. And structural performance of the NOF and OF portion of the dam and foundations. Spillway gates. You should check for the rubber seals, pinion, chains, ropes, if they are properly greased or not. They correctly open and close. This, of course, a ritual practice of inspecting the gates every time before pre-monsoon inspections. You should have a separate generator provided in case of power failures, like that. Then spillway bridge, then hoist bridge, trunnion level bridge and catwalks. They should be intact and they should be accessible. Inspecting person should pass, should reach there and view the components. And energy dissipation arrangements comes next. There are many forms of the energy dissipation arrangements, like regular steering basin or chute spillway or ski jump or dented friction blocks or like that. There should not be any erosion or accumulation of grit. Why I specifically mentioned the accumulation of grit is that though your concrete is good, but in high floods, many a times this accumulated grit churns inside the roller formed by the water, and this does erosion effect on the bed of the spillway. So such accumulated grit it during the repairs or any maintenance or like that. So we should not allow any grit to get accumulated. It should be removed prior to the monsoon or spillway starts. Then guide walls, divide walls, plank walls. If they indicate any abnormal drainage or weep holes functioning abnormally, you should be very much careful to find out the reasons of such increased weep hole flows and like that, and end wear. Again, it should be intact. Particularly, I would like to mention the category 6 energy dissipation arrangement. We happen to go to Goa as well. There is one large dam named Anjune. So there, the Stilling basin, is inundated every time by more than 3 to 4 meters. It cannot be drained out easily. So we make it a point that every 3 years, this Stilling pond is totally drained and it is inspected and videographed again. And then if any abnormal erosion is seen, then we take care of repairing those. So few dams have a few specific problems, so we must take care of all that. So hydraulic performance of energy dissipation arrangement should also be observed. Instrumentation installed and observations. So what normally instrumentation we should see on old dams, particularly the new dams, if they are gravity dams or the spillways of masonry or concrete type, we have thermometers and all, stress and strain meters, but they have the significant for first 5 to 6 years. Afterwards, the temperature in the body of the dam is maintained, and we should not bother about that. But for regular inspection, we should take care of the tilt meter, which shows the tilt of the dam. You know, when the dam reservoir is full, the dam has a tendency, if it is elastic dam. I'm not speaking about the earthen dams or plastic dams. The elastic, that is masonry and gravity and arch dams, we don't have any arch dam. So masonry and concrete dams. So they have a tendency to bend slightly, tilt downwards when the reservoir is full, and bend slightly backwards when the reservoir is empty. So this allowance of the tilt is measured and is specified. So you should not see any additional tilt in the tiltmeter during the monsoon or even in the dry season. So this record is permanently maintained and the tilt meters are permanently repaired and maintained. Then instrumentation, then strong motion oscillograph, particularly in gravity dams, in seismic zones, you should check these strong motion oscillographs. They are working properly, because seismograph can be kept anywhere, not necessarily on the dam. And I say that it should not be placed on the top of the dam or anywhere in the dam body. Seismograph, if you want to monitor the seismic activity in your dam region, it should be placed on strong strata very near to the dam and not on the dam. So forget about the seismograph, but take care of the strong motion accelerographs installed in the galleries and top of the dam. Normally, we install 3 strong motion accelerographs, one on the top of the dam, one in operation gallery, and one in foundation gallery. And we monitor the recordings on him, particularly every after small earthquake. In case of Koyna Dam, I will tell you that they are activated only after a earthquake of say 4 magnitude. Below that, they are not activated, so we don't have to worry about them. If the earthquake is less than 4 magnitude, 4 Richter scale magnitude, then we have to see the V notches in the body of the dam in the gallery, and as I mentioned earlier, in the earth dams. So we should keep a clean record of these V notches, the flow through them. The V notches should be desilted, and again, if there is a leaching, we should clean them. We should check the measuring plates on them, and they should be maintained. Then stress strain meters, if any, we should keep a watch on them. Then I mentioned earlier, as I mentioned, the piezometers, then cross and flow drains, the discharges of them, relief wells, discharges of those, they are all checked in all the dams periodically. Then approach bridge operation platform and cables for outlets. I need not elaborate it. And outlets, yes, outlets may be at different levels. Irrigation outlets are there. Then power outlet is there. So outlet gates. Then reverse race, if it is there, the power outlet, it should be checked and seen if any abnormal deformities are seen in that. Emergency preparation and safety. Access roads, they should be all time accessible. And communication facilities, this is very much important. Last but not the least, these are the communication facilities should be there to communicate, in particularly in heavy rains and downpours, and while the spillway is operating. Because nowadays mobile network is everywhere, and you can communicate on WhatsApp and SMS and calls. But at many places, because they are at remote places, this network of your mobile towers is not available. I will mention Anjunem Dam in Goa. No network is available. In Koyna, in the rainy season, many times no network is available. So VSATs or wireless communication or hotline communications, they are very much necessary to keep a rapport with the higher authorities during rainy season and during spillway operations. Then hydraulic risk assessment, I will come to this now, the second part of our lecture. All dams during design phase are designed for all sorts of hydraulic risk resistance. You everybody know about it. So there is hardly any problem arising out of hydraulic risk. The hydraulic risk for dams arises only during the exceptional flood conditions. Similarly, during high floods, the population in the downstream on the river banks is also affected. So this is because of following many factors. So hydraulic risk assessment, if participants are from Maharashtra, just a month ago I had written one article to be prepared for the floods, or in Marathi, Purasati Susajjata. And that was very well published by Maharashtra Times. If many of you have read it, these contents are included in that. For those who have not read, it will be just a new thing to them. After 2005 incidences of heavy downpours, cloudbursts, exceptional floods, and locally concentrated very high rainfalls have increased. This could be because of the global warming, environmental changes, and changes in the oceanic currents. everybody knows that two imaginary lines are considered in case of river basins, blue line and the red line. The blue line indicates a flood level which can occur in 25 years period, whereas the red line indicates a likely flood level that can occur in a span of 100 years. The lines can never be permanent because every time when a reservoir of marking these lines, when a revision of marking these lines, they will change the levels. If you consider a span of 25 years, which falls 100 years back from now, then there was less population, less congestion of residential and commercial buildings. Farming was also limited to certain farmlands and not encroaching in the river banks. There was a lot of vegetation on the banks of the river, and the roots used to hold on the soil mass on the back and on the bank, and the soil erosion was less. Now, if you consider yester 25 years, then everything is changed. Growth in the population, growth in buildings, construction, encroachment on the river banks, deforestation and erosion of soil mass, farming and gardening on the river banks, deposition of debris generated through new construction, then leveling of the plots and all. It has reduced the waterway and hence flood levels are rising all the time. This has a large effect on the blue line, though the difference will be slight in the red line. Now, I must mention one more thing, that the communication routes and building of bridges has also increased in the last 25 years. And the bridge and the embankments for the roads have again created obstruction in the natural drainage of the land. And the bridges, if the waterway is not calculated correctly or is not calculated for 1 in 100 years or 1,000 years flood, it is definitely going to create a bottleneck in the river flow. And this will again affect the flooding conditions. So I had proposed that in monsoon period, when there is heavy rainfall and heavy floods are being released in the river and the river is flooding above risk level, then we should have a satellite imagery or drone imagery, and we must earmark the areas where exactly the bottlenecks are observed. We can see it very well easily by seeing the spread of the river. So we must check these points, why these bottlenecks have occurred, what are the obstructing things. If the bridge, it has got sufficient waterway, if any encroachment or anything, we must take care of them. Then common people have a notion that those lines, that is the blue and red lines, are generated through vindictive considerations and they are manipulated as per the political will and pressure from builder lobby. Yes, the builder lobby always have pressure because they want to build and we object. But the fact is these lines are decided on statistical data and they cannot be changed, lowered or raised at anybody's whim. Unauthorized building of residential and commercial complexes below the zone of blue and red lines. Farming on the close bank of river will definitely increase the risk to the health, wealth, and lives of the population in general. Particularly, since we are talking about Maharashtra, if you see on banks of this Krishna, Panchaganga, and all these rivers, we have built many Kolhapur type bandaras. And farming is allowed on the banks of the river by lifting water from the Kolhapur type bandaras. So farmers have attended the river. I have seen this on the banks of Kara, Nira, and all such big rivers, that farmers create lands by depositing material imported from outside and They reach up to the banks of the river and create farms, and particularly they grow this sugarcane on the banks. And what happens when the flood is passing? The sugarcane stems obstruct the flow, and it is are formed in between the crops, and the total rugosity of the banks of the river is is spoiled, and the velocities in the river, flood velocities are reduced, and they also cause a rise in the flood level. So this should be avoided, it should be taken care of, it should be banned. Of course, to control the releases of flood from the dam, there is a definite science known as reservoir operation schedule. This tells the engineer in charge about the levels to be maintained date-wise throughout the water year of a particular dam, particularly in monsoon season, not afterwards. But afterwards, yes, when the dam is multiple purposes, then you should not allow excessive water to be used for power generation, excessive water to be used for irrigation, excessive water to be used for drinking, because there are reservations. Accordingly, you must know how much release should be there from the dam every month, every 15 days, and you should keep a watch on this reservoir operation schedule. You know, so this is prepared on maximum available rainfall data of a particular dam catchment. On this, assuming a 75% dependable yield and 90% dependable yield of every 10 to 15 days, the certain water contents of a dam are derived. Corresponding lake levels are correlated, and from the area capacity curve, and that level in the reservoir shall be maintained behind the dam till the monsoon season recedes, and again after the monsoon season as well. So these are the general zones considered in the dam when you should be particular. Dead storage, you know, you don't bother about that. It is specifically meant for accumulation of the silt in the 100 years. So even we keep the control gates above this level. So this dead storage is dead storage. We don't have to worry about that. And it is there every year. Then buffer zone. So buffer zone normally is a carryover which we specifically maintain after or in the at the end of May or the end of summer, because it's likely that many times the monsoon does not start in time in June. It nowadays particularly it starts in July. So you must take care of the water supplies required for everything, for farming, for drinking, for industry, and all. And you must keep a definite reserved water quota for June up to 15th of July, I will say. So you should be able to supply water in up to 15th of July if the rains don't start and the inflow is not established. So this much water you must keep. Then when the water actually starts coming, the inflow starts coming, then it is the conservation zone where we must store the water. Irrespective of how much inflow is coming. So we don't have to bother about the levels till now. Now the flood control zone here, particularly when the period of the dam fills up to the crest level, you must take care of the levels. It should not reach the crest level very fast because of high floods. You must maintain the water level in this flood control zone. And then the spill zone. When the water reaches the crest and goes above beyond the gates, then you should take or monitor the inflow and maintain the levels in the spill zone until the end of the monsoon or monsoon recedes. So during 2015, latest ROS of Koyna Reservoir was formulated. It was formulated by me, considering a huge rainfall rate of 1962 to 2015, 53 years. It is shown below. So this is just academic information. But from 1st July to 10th July, some certain level should be maintained. So up to 21st and 31st of October, this level shall be maintained. That is the maximum full reservoir level, 2163. You know. Now, it is not possible to stick to a designated level in every year. Because this depends on how the rainfall pattern of a year is. That is, if the predicted rainfall in a year under consideration is less than average, or say equal to average, the levels are reached late or as per schedule. So, the officer in charge does not have to bother about the water levels. But if the rainfall is more than average, then he has to manage the water levels up to the stipulated water levels. And this is achieved by early releasing water from power sluice and river sluice if needed. So even in Koyna, we request the generating authority to release waters through power sluices and generate. But what happens in the rainy season, there is no demand for power. So the Mahajanko is reluctant to generate in the rainy season because they want to conserve the water, the quota allotted to them for the dry seasons, because the demand of power is high in those months, particularly from January to May. So they are reluctant, but we must force them that to maintain the level, the reservoir, you must release some water. And we release water from these, as I said, power sluice and river sluice, but that release is very meager. So you cannot control the heavy floods if they come, and you are helpless, and the water level reaches above the stipulated level, because even the controlling from the power sluice and river sluice is not sufficient. So many times, if the rainfall is very high, the releases from the power sluice or river sluice are not sufficient to maintain stipulated level. In that case, of course, the levels stay higher than the stipulated levels. So for every dam, two curves are plotted. One is said to be a good year curve, and the curve of dead to level, reservoir level. So that is the curve. So a good year curve, and the other is said to be a bad year curve. So bad year curve is the lower one, because when the year is bad and the levels are reached late, so that is the bad level, bad year curve. And the good year curve is a normal or just above the normal curve. So it is seen that the level shall be maintained between these two curves. So the operating engineer takes care of this as far as possible. If not, then you don't have any control over them when it is very heavy downpour, like say this year or in 2005, 2006, 2019, 2021, many occurrences were there. So it should be borne in mind that until the reservoir level reaches to the crest of a gated spillway or non-gated spillway, nothing is in the hands of the engineer in charge. As I said, because you cannot release sufficient water from sluices. So let us wait until the water comes to the crest. But once the reservoir level reaches the crest level, then there can be a control on the releases of flood water. If the dam spillway is ungated, then the engineer in charge can do nothing but see the flood spills over the spillway. It is ungated. Water spills. So what the engineer in charge can do is just sit in his cabin and have a cup of tea or coffee and watch the spill going. But normally in our Maharashtra or anywhere, with large major dams which have a major hazardous potential, they are always gated. In nearly all the major dams, the spillway is gated, and the engineer in charge can keep a proper control on the releases of the flood water. So when the reservoir level reaches up to the crest level, then When the reservoir level reaches up to the crest level, then the engineer in charge keeps on calculating the inflow by either empirical methods or by measuring the water levels in successive time period. For many years, till I was the chief engineer, I was superintendent engineer of Koyna project, measuring the water levels in successive, for many years in case of Koyna Dam, it is observed that when a rainfall of 1 inch occurs at Mahabaleshwar, then after 6 hours, zero point 0.6 to 0.7 TMC of water inflows into the dam. From this, a fair idea of likely flood coming into the dam within 6 hours can be calculated. So, in 24 hours, there is a rainfall of say 200 mm. That is say 20 inches or something. Okay, I should 20 inches at Mahabaleshwar. Then how much amount of inflow is going to be there? So 20 into 0.7. So it is 14 TMC. So 14 TMC of water is going to come within 6 hours in 24 hours. So that we know. So from this, a fair idea of likely flood coming into the dam within the 6 hours can be calculated. Otherwise, if rainfall is scattered throughout the catchment area, then the engineer observes the water levels every hour. Then he takes the difference of levels, say after 6 hours, and calculates the total inflow received in these 6 hours. From that, he can calculate the rate of inflow, and accordingly, he can release the water from the spillway or withhold the flood if he can in the flood absorption capacity of the dam. Because in any case, there is limitation for releases from the spill to the extent that the capacity of the spillway, how much it is. Unfortunately, when I will tell one specific case of Koyna Dam that the maximum releasing capacity of the Koyna spillway is 2,54,000 cusic. But no sooner we release a discharge of 1,30,000 cusics in Koyna River, the Irving Bridge at Sangli inundates. So we cannot release water more than 1,30,000 cusics. We have to control it, and we have to absorb it in the absorption capacity of the dam. Recently, I had proposed the CDO that in many dams, because as I said, particularly considering the Krishna River, there are many dams, and when there is a heavy rainfall, then every dam starts releasing. And of course, there is a danger of flood and inundating the Karad, Sangli, and such villages, such towns. So, what I had requested the CDO that watch the water level and assume that if there is a large inflow in Koyna Dam and we are releasing only some say 1 lakh cusics, we don't want to increase it considering the danger downstream. So, calculate how much water level rises in the reservoir, even it encroaches in the high flood zone, and check the stability analysis of this dam. Because say we know that heavy downpour never lasts more than 24 to 30 hours. Afterwards, it recedes. So we definitely have a time period of say 30 hours to store the water behind the dam without releasing it or releasing in a limited quantity. What will happen? The water level in the reservoir will rise and will encroach in the high flood zone. Calculate the stability of it. If it is okay, allow the officer to control the flood and allow the water level to rise. And if this can be done, then we can have a definite control on the floods, because small dams can release water, and releases in the larger dams can be controlled for some time till the heavy rains recede, and then we can release. So thereby, we can have some control on the floods. Let us see if it works. Generally, the height of the gate is around 5 meters, and thus the crest level is 5 meters lower than the full reservoir level. So the engineer in charge has a sufficient time to monitor the levels in this flood releasing zone. But if the reservoir has already reached the FRL, this is a crucial condition that, okay, the monsoon is over, the 31st September, 30th September has passed, 15th of October has passed, and the dam level is full as per your reservoir operation schedule. So the engineer in charge has a sufficient time to monitor. But if the reservoir has already reached the FRL and then late monsoon occurs, this happens nowadays every time. Then the inflow cannot be retained behind the dam and has to be released in the river. While releasing the flood, a watch shall be kept on the main river downstream so that heavy floods do not inundate the properties of the residents downstream. For this, flood monitoring units are established at crucial spots on the bank of major rivers, and from them, using the real-time data, different dams are directed to release measured flood through the spillways. So they are 24 hours operating in the monsoon, and they are connected through computers and connecting via VSATs and wireless and even mobiles. So on-spot judgment of the engineer in charge is very crucial. If considering the risk of anticipated floods in future, if he maintains a lower level and start releasing floods in advance, and if the monsoon suddenly recedes, then the reservoir does not fill to the FRL. On the other hand, if the rainfall is normal and by the end of the rainy season the reservoir is full, and if the return monsoon brings in heavy rainfalls and creates floods, then the flood cannot be retained behind the dam, and there is no control on the floods occurring downstream. I every time say this. I have every time published through medias and even on videos. On TVs and networks, that you don't blame the dams for the floods. I specifically mentioned that considering the Sahyadris even, only 15% of the catchment of the Sahyadris is stored or blocked by the dams. Rest 85% of the free catchment area straightway drains into the Krishna basin or Bhima basin or whatever it is. So the dams are no way responsible for the floods occurring in those months, because free catchment also drains for 85%. Fortunately, on the earlier months of monsoon, say July, August, the dam has not reached the crest level. So major rivers, even though there are floods, they are not released into the river, but they are stored behind the dam. And thus, a natural control on the floods is occurring due to the dams. So dams are absorbing these heavy floods until they are filled up to the FI. So they help in controlling the floods. And even after that, dams are not structures who create or generate water. No, they can just store water for the benefit of the population. And they are filled to the brim. They are full. And now the flood comes, or the heavy rainfalls, particularly of the return monsoon. They come, then the dam can do nothing. The water has to be released. Suppose there were no dams, then all this flood might have straightway came into the river and might have flooded. So don't blame the dams. On the contrary, dams help in monitoring the floods. This is what I every time keep on mentioning. Nowadays, the monsoon status is watched by satellites, and a fair idea of percentage rainfall is known. And time to time, real-time warnings of concentrated rainfalls and alerts are broadcasted, and thereby the engineer in charge can stay alert and makes good decisions. The new softwares like HICRAS, Mike 11, Rebasin can predict nearly correct water levels in the valley occurring due to certain releases from the spillways and from free catchment areas, and can help the revenue authorities and population downstream to be alert and shift the belongings in time to safe places, thereby reducing the risks. Particularly, we have observed when we were monitoring this flood of Chiploon in 2021. I was the chairman of the study committee, uh, and people were blaming the powerhouse, Alore powerhouse, for releases and doing the flooding. Funny thing is, 250,000 cusecs flow was flowing through this Vashishti river and Jagbudi river, and how much maximum discharge a Kolkiwadi powerhouse can release? You know, it is 11,000 cusecs only, as compared to 250,000 cusecs of water in Vashishti river. Only 11, and then only 2 or 3 generators were operating. So the release was not more than 7,000 cusecs. So people just find somebody to blame because they want compensations and all that, and raise a hue and cry against somebody to blame. So unfortunately, we are the people, we are civil engineers, the owners of the dams and the powerhouses, they are all the time at the target. So then I said, I have written that the hydrology wing of the water resource department, which is situated at Nashik, and it is headed by the chief engineer. Their duty presently is what they just certify the availability of water if a new dam is proposed, even it is a small dam, or large dam, a major dam. Water availability is certified by this hydrology department. What I had proposed that this chief engineer should be given some more responsibility, that these softwares are now available, HECRAS, Mike 11, Rebasin, and all. So he should consider each river which threats the population, and then hypothetically assume some rainfall in some specified period, or say in 24 hours, if the Vashishti basin receives a rainfall of 400 millimeters, how much flood is generated, to what level the flood can reach in that particular basin. This you can predict with these softwares like HICRAS and all, and publish the maps of these inundation maps of the rivers, considering it is as a dam break study. Suppose there is a dam break and the flood comes in with this much amount, considering, as I said, assume a rainfall of 400 to 500 millimeters in 24 hours, and publish these maps and hand them over to the revenue authorities. Then say in earlier 24 hours, there is a record of say 300 millimeters in a particular rain gauge station in a river basin. Then find out the maps. You can calculate what will be the flood level in that basin. You can see how much area is being inundated. If there is any population, there are, residential areas, commercial areas, and whatnot. Then you can just spread the notice, alert, and ask the people to shift to a safer location above that level. Then the risk of these floods will be minimized. Again, we have monsoon models. And earlier, I don't remember when, but Dr. Gowarikar had published his monsoon model, and that was hype. But he, as I know, he had considered some 32 factors in it. So the more factors affecting your model, the more complicated it goes and more likelihood of errors occurring in that model. So by now, in last many years, this tropical meteorological department might have modified the uh, monsoon models, and they might have arrived at some good assumptions and good predictions about the monsoon. And further, it was debated earlier about the monsoon model of Dr. Gowarikar, Vasant Gowarikar, that predicting a monsoon of total India is nowhere to lead us, because India is such a huge country that if you say this year you will receive 100% monsoon, yes, how can we calculate this average area? In Himalayas, it can be 120%, and at Kanyakumari, it can be 80%. The average is 100%. At Assam, it can be 70%. At Gujarat, it can be 130%. The average is 100. So when you said 100, you cannot say that it will not exceed anywhere in the India. Or when you say it is 70%, then you don't sleep with the idea that we don't have any problem of flooding the rivers and no botheration about the flood controls of the reservoirs. No. Localized rainfalls always differ from the averages. So, better idea is to divide the India in 5 regions. So one is east, west, north, south, and central. And then if you can, I mean, the model can give ideas about the average rainfall occurring into those areas, then the dam authorities can definitely have some, I will not say full, some good idea about the assurance of rainfall, or they can even plan the crop pattern, they can even plan the water releases, and accordingly they can manage the storage there. So these things can definitely help the managing authorities of the dams, reservoirs, and powerhouses as well. And then they can manage holidays to the thermal hydro generating powers, nuclear generating powers, and utilize the hydro potential during monsoons if the prediction of monsoon is high, particularly in that area. And then the management of the risk management of the people downstream of the dams can be handled correctly. So thank you very much. I have tried to communicate, tried to explain the topics as per availability of my data. And if anybody has any doubts, and if I can't clear them, I will reply. And if not, I will jot down the question. You can mail them to me, and I will try to reply them. So,
Thank you, sir.
yeah, yes.
Now we will go on to the question answering session. I request the
Sure.
participant, if they have any questions, please do be free to ask, sir. Any questions from participants? Request participants to ask question if there is any query.
Okay, before I conclude, I would like to add one more statement about the dam safety. Particularly when we bother about the dams in the earthquake zone, it is stipulated that whenever a earthquake of intensity more than 4 magnitude occurs, the superintending engineer himself has to reach Koyna and inspect the dam, because the dam is vulnerable. And then what we observe is the releases from the monolith joints, they increase surprisingly. And turbidity increases in those monolith joint leakages. But after 24 hours, it comes back to normalcy. So this phenomena was explained earlier because there are, I mean, what to say, monolith joints are treated with copper plates earlier days. So during earthquake of 11th December 1967, the dam was shaking, and because of different heights of the monoliths, the natural frequency of the monoliths was also different, and the copper plates have sheared, and thereby the water from those monolith joints had increased, and we still monitor the leakage, try to reduce it by treatments. From there, this leakage increases, and again it is monitored. I mean, it settles after 24 hours. So any dam engineer, when particularly he is in zone of say seismic zone or anything, while inspecting the dam, he should be very much careful to see these things. But fortunately, the earthen dams are very much vulnerable, non-vulnerable in earthquakes. They are plastic dams; they settle by themselves, and no hazard is caused normally to the earthen dams, unless there is some failure in the outlets. If it is a failure in the outlets, then naturally a great piping happens, and earth dam is likely to fail in earthquakes. Otherwise, no threat to the earthen dams in earthquake. Well, thank you.
So one
Question?
more question is there from Shahista Tiskar.
Yeah,
She
please.
wants to know, can we give modern technology in dam safety and how it will be applied?
Uh, Modern technology in building of dams, or what? I don't understand the question.
Modern technology in dam safety.
Huh. In dam safety, yes, it is utilized. As I told you already, we have established one hydrology department which predicts the dam inflows and all. We have alerts, we have radar systems which tell about the inflows to be occurring, the rainfall to be occurring in recent 24 hours, and that prediction is very much accurate. And we can definitely monitor. And as I told, unless the water reaches to the crest, you don't have to bother. When you have to bother is only after the dam reaches to the crest and there is a warning of heavy rainfalls, and then we can monitor. And yes, we already have this, I mean, what to say, advanced technology in predicting the rainfall and monitoring the floods. But unfortunately, we cannot add more gate to the spillway of the dam, because now when we are, I mean, in Maharashtra, we are not constructing any new dam because we have exhausted all the water allocated quota for the Maharashtra. But old dams, now their discharges are established, their maximum flood is established. There are total settlements on the banks of the river. So we cannot, for safety measures, add any more gate to the spillway. On the contrary, we have to control whatever spillways are there, and we cannot release them to the maximum extent. So only thing, as I said, we must take care of the dam, watch their tilt, then watch their stability during high floods and flood absorption. And fortunately, with advanced technology and with large, very good softwares available, you can do it instantly. And you can monitor the stability of the dam. So that gives you safety measures, or safety assurance of the dams. These are definitely the advancements in days as compared to our days. Is
Sir,
that
even
are,
Shashikant Gosavi sir has a question.
please?
What measures are possible to stop recurrence of flood at Kolhapur Sangli due to Almaty Dam?
Now let me tell you. This study has been done by many institutes, many renowned institutes, and even our departments, this interstate dispute board and all. Then there is no definite effect of Almaty Dam on the Maharashtra, Sangli, Panchganga, and other rivers, because the FRL of the Almaty is very much 20 or more meters below the Rajapur Bandhara or the river basin at Krishna, Panchganga, and all that. So the Almaty does not have a definite effect on the floods in Krishna. So this concept that the Almaty Dam has caused the floods in 2005, 2006, 2019 and all, that is not correct. So please don't be under impression that Almaty Dam has any effect. Now, few fellows, of course, argue, even that is done, that say, considering, you don't know the Manning's formula, the effective gradient of the river has a what to say, control on the velocity on the canal. So when the Almaty is at zero level or at crest level, the effective flow, bed slope of Krishna is some certain figure. If the height of the Almaty Dam is raised or the flood is raised in Almaty Dam, then the effective bed slope of the river near Sangli, it reduces. Rugosity is reduced and rugosity is increased and it creates floods. But unfortunately, no. It is just blaming the dam for just hiding our own encroachments on the river, nothing else. Thank you. You may not like this answer, but it's a fact that don't blame Almaty Dam. You must introspect yourself. Have you done any encroachment on the river flows in Panchaganga or I mean, this Krishna and all?
Yes, sir. One more question now. So what is your view about sedimentation of dams, especially about Western Maharashtra region? This question is from Vishal Kumbar, sir.
Yes. Very good question. I wanted to reply this because, yes, listen to me, that we have already kept a pocket of pocket of silt, which can be accumulated in hundreds of years, studying the siltation rate of area. Second is our Sahyadri range, in Sahyadri Ghats, hardly average 4 to 5 meters overburden of soil is there. Below that is a hard strata which does not erode. So silt accumulation in the first 5 to 10 years occurs, and that settles mostly on the bed or in the dead storage. And thus, it does not reduce the, I'm talking about major dams only, it does not reduce the silt in the, it does not reduce the contents of the dam because of only the silting. So there is no silt. We have studied the Koyna Dam or many other dams, hardly 0.03 or 0.05% of the storage is affected by this silt. Yes, for minor dams, because on the banks of such dams, farming is always there, forestation, deforestation is there, silt is generated, that is accumulated in minor dams, and earlier, the government has permitted the local fellows to take out the silt for their farming, but at their own cost. The department will not charge for this silt and will not compensate for the expenses incurred by the people for taking out this silt. But that is very minimal amount, and localized effect on the storage is there for these minor and medium tanks. But for major dams, there is no silt accumulation so far. But this hue and cries every time there about the silt. Just about the Khadakwasla is one dam where silt accumulates every year. But the storage of Khadakwasla is not a concern because it is fed by Panchat, Varasgaon and Temgar dams for drinking and industrial water for Pune. So again, but the silt is removed by many NGOs, and that dam is again rectified. I mean, the storage is restrained, storage is restored. So only this silt accumulation is a need. I mean, the story of silt accumulation is in need of few professionals who want to utilize their tools to do some work, nothing else. Yeah. Anybody else?
Thank you, sir. One more question is there. 1 minute, sir. From Shashikant Gosavi, sir. Are we starting to fill the dams in from downstream to upstream seriously?
dams from downstream to upstream.
I'm not able to understand the question either.
I haven't understood because dam fills by the inflows every time. There are no such dams like downstream and upstream. There are Kolhapur type bandaras. And yes, they can be monitored. They are not, they are empty and filled as per the requirement and from the flow of the main dam. So there is no practice of filling in. They are filled in the rainy season, not in the rainy season, after the rainy season is over. And they are filled from bottom to top, always from downstream to upstream, Kolhapur type bandaras. But they are stored after 15th of October. They are not filled in, the gates are not lowered until 15th of October. So Kolhapur type bandaras, yes, they are filled after the monsoon is over from downstream to upstream. For dams, there are no such cascading dams in our Krishna basin, apart from this Ujjini dam.
Okay, thank you, sir. Anybody from the participants who wants to give a live feedback, please be free to give the feedback. From the participant, please unmute yourself and give the live feedback, please.
Yes,
Somebody,
sir, it was very nice and informative session. The details, basic instrumentation required and gravity dams, everything you have given was very useful, sir. Thank you for the informative session, sir.
Thank you very much, Dr. Prashant. Thank you very much.
Anybody else? Thank you, sir. So let us go on to the vote of thanks. On behalf of AGTI's Dr. Dawlatrao Ahir College of Engineering, Karad, and the AICTE Atal FDP, I extend our sincere gratitude to Engineer Deepak Modak sir for delivering an insightful and highly informative session on dam safety regulations and hydraulic risk assessment. Sir's session provided a clear understanding of regulatory framework governing dam safety, along with practical insights into hydraulic risk assessment, risk identification, and mitigation measures. The emphasis on proactive risk management, safety protocols, and decision making frameworks highlighted the critical role of dam safety in disaster risk reduction and resilient infrastructure development. The session greatly enhanced participants' awareness of importance of compliance, monitoring, and data-driven assessment in safeguarding critical water infrastructure. The interaction, discussion, and clarification of real-world challenges further enriched the learning experience. We are thankful to Engineer Deepak Modak sir for sharing his valuable expertise and contributing meaningfully to the success of this FDP. We deeply appreciate his time, effort, and commitment to capacity building in the domain of disaster management. Once again, thank you, sir, for an excellent and impactful session. Thank you, sir.
It was my pleasure. Thank you.
Thank you, sir.
Thank you, sir. Very nice session. Hello. Oh.